Hello all, this is a foundation tutorial on machine learning with natural language processing examples. So this tutorial will give you an overview of machine learning techniques and its categories. So what is machine learning? So machine learning is a subfield of artificial intelligence. It can also be a thought of an application of artificial intelligence. So when I think of machine learning, the image which is on the right hand side pops up in your brain. So like machine is learning on its own. Of course, that's right, because the machine is actually learning on its own based upon the previous experiences. It comes across the data given to it, and also using the statistical analysis of the input data given to it. So this prevents large number of code explicitly programmed by the programmers. So now, we said we'll give natural language processing examples, so we should also know what is natural language processing. So apparently natural language processing, that is NLP, is also a subfield of artificial intelligence, which deals with the computational analysis of the human written languages, and also it also deals with the human spoken languages. So there are so many applications of natural language processing domain. So one interesting application which is recently trending would be the Google Assistant. So you ask the Google about anything, it's just through voice, or you just type, it just responds with the help of the data it is stored inside it. So that's a very good example of both natural language processing and machine learning. Yeah. So how do machine learning and natural language processing connect? Yes, as we saw earlier, even the Google Assistant is a very good example of both the machine learning and natural language processing, because it understands your language, either given in the form of a text or in the form of a speech, and it learns the connection between your query and the relevant answers that are hidden on the web, and it learns on its own and analyzes it and gives back you the answer. So now there's existing the natural language processing and the machine learning techniques. Let's think of another example, another scenario wherein we are given a raw text, a collection of raw text. Say for example, we are given 100 documents, and our job is now to categorize them depending upon their topics. So let's say we are interested in only 3 topics. So out of these 100 documents, our job is to categorize them based upon their topics. Say for example, we want to classify them into sports category, or a fashion category, or a technology category. Okay, so how do we do this? So, in one way of doing this would be like we can have some clues to know about the topic of the text document. Let's say the clues are obviously the clues are going to be the words, because the words present in the documents are the representative of those documents, and the representative of the topics of the documents, and they are the brilliant clues for the particular document. So let's say I find the word football, and I calculate the frequency count of it, because the frequency tells about the frequency is a very interesting factor, because the more number of times a word occurs in a document, the more number of more influence it has got towards that document's topic. So that's the intuition. So here we have considered 2 types of features. We are considering unigram features and bigram features. So we'll tell you what is unigram. So unigram is nothing but a gram is a word or a character. So here it is a word. So unigram is a single word or character. In this example, we are bothered about words only. And the bigram is a 2 consequent characters or words. So here it's again we are bothered about words. So let's say I come across the word unigram word football, and I calculate the frequency count of it, and I come to know that it is 100, and I also calculate the another word which is mobile, this is 300, and I also calculate the frequency count of the word mayonnaise, and come to know that it's the count is 450. Now, at the end of this analysis, So if I find that the word football count is greater than, actually that is not the scenario here, but if at all the football count was higher than the mobile count, then we can classify the document as sports domain. So else it would be classified into the technology class. Okay, so now what we have done is that we have given a set of data. So we just created some features and we calculated the frequency count, and we neatly categorized them into their topics. So now think of the same scenario, but the difference now is that you're given a large number of maybe million number of documents. So think of Google, it is scaling, it is crawling million and trillions of web pages on a daily basis. In that case, the categorization, even Google does categorization. So when you type a particular document, say for example, you give a query, Sachin Tendulkar. Not all the documents containing about so numerous number of documents may contain the word Sachin Tendulkar, but not all the documents are properly are provided to you on the first 10 rank. So they are cleaned, they are pre-processed initially. They are classified, and so which documents actually contain about him, so they are given to you in the first place. So in that case, so when you are dealing with million number of documents, it is not possible to categorize them manually with a few number of feature sets. So you can't, you still can't do patiently and categorize them. How we proceed? So here's when machine learning comes to our rescue. And so again, so we'll take the same example, text classification. So now we have category names. Of course, we need to know the categories beforehand, and we also need to know the frequency, or we can also have the probability count. That would be even better. So using this feature set, so we can categorize a document based on that. So given a large number of data and a large number of features, so we can have we can calculate their frequency, and with the trial and error methodology, we can even filter the features. So we need not first we need to calculate the frequency count of all the words, and then what we can do is that we can filter them based upon their probability. So say for example, a document is containing 100 number of words, then the word Sachin Tendulkar has occurred some 20 number of times, then it is this particular word has seriously related to the topic. So because out of 100 words, 20 number of times Sachin Tendulkar has occurred, so it has to be given some amount of weightage. So this becomes one of the features. So we can have even a pre-step before one more step before feature selection. So we can have a feature selection, and then we can go ahead and categorize them based upon their probability count. So one more interesting thing also it is possible to do here. Not always you can have entire coverage of features provided initially. So that's not also possible because with increasing number of documents on a huge size, so it's not possible to initially provide the features. So in that case, what we can do is that we start with an initially small set of documents with a small set of features, and we can later augment them through iterative learning. So then we can for instance, let's take the word goal. So the goal was given as a feature. So instead of only concentrating on this word goal, so we may also augment this feature by taking the context word features along with it. So because the context is a very good helper to extract some more feature. This is maybe a football. A football accompanies, so we call it as a context word or a neighbor word. So accompanies more number of times. Now we can calculate how many number of times football and goal has co-occurred together, and we can calculate their probability. If they are really high and they have, we can have a threshold like we can set a threshold of 0.5 probability. So we can set so those pair of words so which crosses this threshold can be taken as a feature. So we can iteratively do this again and again for the entire training set till we don't come across any new feature. So that point you can stop. So that way also it is. Having understood about the feature identification, we now need to know what is, we can now understand clearly what is supervised and semi-supervised model. And one thing we missed in the last slide was about the training and the testing, which are the two important process of machine learning model. Feature identification is done in the training, and once you're identified with the features and you keep it aside and you test your model. So if it, for example, you're given totally 100 documents, you can divide them, these 100 documents into two sets, namely a training set and the test set. So say I've used 600 documents for training and 400 documents for testing. You identify the features either by single iteration or iterative, whatever. You identify the features and keep it, and your model is ready. Now, using the features identified from the training set, you test your model on the test set, which is 400 documents, and using this test set documents, you can calculate how efficient was your feature identification. So that's about the training and testing. So now we'll understand what is supervised and semi-supervised model. So as we saw earlier, so we given a test classification task. Either we can identify the features in one single shot, either by given a set of words, we can identify the words based upon their weightages, probability, everything. In one shot, we can do this. If we are not interested in doing in one iteration, we can also do it in a step-by-step fashion by initially giving some seed features and then iteratively learning their context features. It's like we did earlier. So that is a semi-supervised model. Um, so here is the overview of the types of machine learning model we have. Since semi-supervised and supervised are slightly different, and but they merge together, so it's not listed here. So the machine learning techniques overall can be divided into three categories, namely supervised, unsupervised, and reinforcement. Supervised, we know. Of course, we know the in supervised model, as we said earlier, we know the classes and we know the features beforehand. And we do some classification or any task depending upon the requirement. Whereas in unsupervised, we do not know the categories of the classes which are normally hidden. So think of Google again, which is crawling the web pages, but it has to group them according to the categories of the documents. But it is not always possible to know the classes beforehand. So usually we need to go for an unsupervised learning. So we do not know anything, but we have to do something. So that's the concept of unsupervised. So we do this by grouping the documents. We'll take the text classification itself. We'll group the documents without knowing the classes based upon the similar words present in them. So we don't even know the features of the documents, but still, so we try to group the documents based upon the similarity of the words present across the documents. So somehow we group them into clusters, and we can fix the number of clusters we are interested in. So that needs to be fixed beforehand. So we'll know about the details of the unsupervised techniques in the upcoming lectures. So that's about unsupervised. So the difference between supervised and unsupervised should be clear. In supervised, we know the classes and we know the features and we do the classification, whereas in unsupervised, we do not know the classes and we do not know the features, but still we group them depending upon the similarity. So we have n number of similarity metrics for that. For example, Euclidean distance or Manhattan distance. We can use them to calculate the distance or the similarity, cosine similarity metrics, for example. We can use them to measure the similarity between the documents, and we can cluster them. So in supervised, we call it as a classification, whereas in unsupervised, we don't use the term classification, we use the term clustering. So the other technique, which is totally different from that of the supervised and unsupervised, is the reinforcement learning. Reinforcement learning can be well understood with a chess game. In chess game, what we do is that in every move, so we either we fail or we succeed or we remain neutral. So in reinforcement learning also, so we it can be used for a similar type of game building. In reinforcement learning, the technique goes like this: like it gives a reward every time you succeed. So even in the reinforcement learning, like unsupervised, it do not know the rules of the game. So you're supposed to build a chess game. You're supposed to, yes, the agent is supposed to compete with a player, but it does not know how to play the chess game. So it takes the move depending upon the rewards it gets in each of the successful moves. So that's how it proceeds. It calculates the ways of reaching the goal by maximizing the rewards. So that's reinforcement learning. So we'll talk about the classification of machine learning techniques. This slide is about the unsupervised machine learning technique, and this the content is already being discussed. So this slide has also been discussed previously. Yeah, so this is about the reinforcement learning, which we also discussed in the previous slide. So so here agent is going to um, uh, take an action from a state S, and based upon the rewards it gets. So without knowing anything about the environments that is depicted in this picture. So, having had an overview of the classifications of machine learning models, so here are few example techniques for each and every type of machine learning model. For example, support vector machines and decision trees are very good examples for supervised learning. In support vector machines, we classify the data points based upon the decision boundary. So that decision boundary classify the width of the decision boundary helps us to separate the two classes. And in decision trees, it's about these techniques we'll discuss in detail in the upcoming lectures. I'm just giving you a gist of what is what here. In decision trees, so decision trees are used in applications wherein we need to take a decision, like for applications wherein we need to decide whether it will rain today or not, or the Indian team will win or not. For such kind of application, decision trees will be a good fit. Semi-supervised learning, as we saw earlier, like we do the training in iterative fashion to augment the features. The Yaroski bootstrapping technique is used, and it was initially meant for word sense disambiguations. About also we'll discuss in detail in the upcoming lectures. And unsupervised learning. So k-means clustering is one example, and hierarchical. In k-means clustering, we group the data points, and we take the data points and we group them if they are similar, and we calculate a centroid, so which is going to be the representative for each and every cluster, and we pull in the data points to this cluster based upon the similarity between the data points which are outside the cluster and the centroid. And so that's about k-means. And in k-means, we need to know the k. So at which point k denotes the number of clusters, at which point we need to stop. For example, we start with 100 data points, and if we fix k as 3, then we need to stop the clustering when the number of clusters reaches 3. That is about k-means. And hierarchical clustering. So it is also similar to k-means. The similarity measures are going to be different. We can, but the way we cluster only matters. Like in hierarchical clustering, it's done in a bottom-up fashion. Like you can imagine as a tree where the leaves are going to be the data points, and the each data point is considered as a single cluster initially, and the data points are clustered together if they are similar, and this is iteratively done when the when we reach the root of the tree, so at the top. So that is hierarchical clustering. And reinforcement learning, Markov decision process, that is MDP, is an example about which also we'll discuss in detail in the upcoming lectures, wherein as we saw earlier, we take decisions and we move forward towards the goal based upon the rewards we get. Yes, sir. Hope you all got an overview of what is machine learning and the classifications of machine learning model. And so in the upcoming lectures, you can have a detailed discussion about each and every technique. Thanks for listening.